4.5, solve quadratic equations. By finding square roots. So basically we're going to be breaking down radicals is like the big thing in this section. So number 4, the square root of 192. So obviously not a perfect square. So I start breaking it down into pieces. So what are 2 factors of 192?
191.
2 and 81. Wait, 2 and...
Zach, what are you talking about?
She's looking for...
96 and 2.
Yep, 2 and 96. Factors of 96.
8 and 32.
3 and 32. Factors of 32.
8 and 4.
Yep. 8 and 4. Factors of 4. 2 and 2. Factors of 8.
4.
Factors of 4.
2 and 2.
Alright, so this is a square root. So when I take stuff out, I take them out in pairs of 2s. So there's one pair of 2s. There's another pair of 2s. There's another pair of 2s. And I'll have a 3 left over that's not going in. So when I have a pair, that means that one of them comes out, because that's like saying the square root of 4 is 2. So this is going to be 2 times 2 times 2 times the square root of 3, which is 8 root 3. So we're just breaking stuff down, basically.
That's cool. What, Zach?
Oh, yeah, I got that.
Zach, make sure you pay attention today so you know how to show your work.
Yeah, I am. Thank you.
And
but I should
write
work
down
on
the
the
work
quiz.
and not just
I haven't graded them yet.
Oh, okay.
Okay.
They'll probably
I
get
just-
graded today, though.
Are quarter 2 grades up yet? Because on grading, I'm still stuck in quarter 1 and I don't have any quarter 2 grades up yet.
I'm a very...
We're at mid-quarter, so yes, there are a lot of grades in
I
for
can't
quarter
see
2.
any of my quarter 2 grades.
Do you know how they say you had to be...
reset the cache and grade link. There's a problem with
Yep,
grade link
I've
right now.
reset the cache.
You have? How do I do that?
Do you know how you're supposed to be confident with...
I don't know, because my grade link doesn't look like yours does.
I don't even know what the cache is.
All right, 6. The square root of 3 times the square root of 27. So when I have square roots being multiplied by each other, I can multiply what is inside of them. So this would be the same as the square root of 81.
Which is 9.
So
9. It's positive and negative.
we know that, which is 9. They are not positive or negative.
It's all positive. Huh, by the way.
These are just square roots.
Oh. Okay.
That's if we're solving an equation.
It's really cool how sometimes we square them, like the square the answer, and then sometimes we circle the answer.
What do you mean?
Like sometimes I'll circle my answer, and then sometimes I'll square them. Or I'll
Yes,
write
that's
them.
so cool.
Is that a veiled complaint or like an actual?
Charlotte's been mean.
I don't know what.
8. 5 square root of 24 times 3 square root of 10. So I can multiply the stuff outside and multiply the stuff inside. So I would have 5 times 3, and then the square root of 24 times 10. Okay, I'm just showing you what it is. You would probably just go straight to the number. Now, the reason that I just left this as 24 times 10 inside is, yes, one, for you to see it. But the other thing is, when I go to break it down, it doesn't really matter what 24 times 10 is, because I'm going to be breaking it down anyways. So I'm just going to use that to break it down. 10 breaks into 5 and 2. 24 breaks into 6 and 4. 6 breaks into
3 and 2.
4 breaks into. So here's one group of 2s. Here's another group of 2s, and I have a 3 and a 5 left over inside. So I have 15 times 2 times 2, which if you want to just go ahead and multiply that to be 60, that's fine. And then the square root of 3 times 5 is 15. So this is 60 root 15.
That's awesome.
Yeah, I take 15 different colors.
It's the same color.
One blue this way, one blue that way.
Right.
10. Square root of 35 over 36. Notice that it's all under one radical. Okay? When you have a fraction under a radical, you can split the radical top and bottom. So this is the same as the square root of 35 over the square root of 36. All right, so square root of 36 is
6.
square root of 35.
No,
35.
Just the square root of 35, because if I break it down, what does 35 break into?
5 and 8.
5 and 7.
5 and 7.
5 and 7. Can those break down any farther?
Absolutely
Nope,
not.
so I just leave it.
30 days. Oh, that's my tiger.
My tiger.
12.
My eye of the tiger.
7 over the square root of 12. So, I'm going to break down 12 because it's not a perfect square. So, what does 12 break into?
6 and
2 and 3.
3 and
Oh.
4.
6 and 2, and Zach 6s.
2 and 3.
2 and 3. So I can take out a 2, I'm left with a 3 inside. So this gives me 7 over 2 root 3. Can I leave it like that?
No.
Why not?
You can't have the square root in
Can't have a radical on the bottom. So I need to rationalize it by multiplying by square root of 3 over square root of 3. We can have radicals on top, just not on the bottom. So when I do that, I get 7 square root of 3 over 2 times the square root of 3 times the square root of 3, which is
9.
3.
18.
3. Square root of 3 times the square root of 3 is the same thing as the square root of 9, which is 3. So 2 times 3 is 6.
Yo.
You're so smart.
So, okay. What's a radicand?
The radicand is the thingy inside man.
Oh, what?
The radicand is the number. The radical is the.
Okay.
So, may I ask why we're not allowed to have the square root thingies on the bottom, or radicals on the bottom?
Irrational.
Truthfully, I don't know. It's just a rule in math. You're not allowed to have them on the bottom. They can't stay there.
This is a dictatorship.
So they just
We're
wanna
staging a
make
coup.
All right, 14. Square root of 13 over 28. So I can split this into square root of 13 over the square root of 28. Does 13 break down at all?
No.
No.
Because it's what kind of a number?
Prime.
It's a prime number.
Optimus Prime.
How about 28?
Yes.
What does it break into?
A 4 and a 7.
4 and 7. 4 breaks into
7 and 2 and 4. 2 and 2.
2 and 2. So take out a pair of 2's, left with a 7. So this becomes,
2 square root of 7.
yep, so square root of 13 over 2 root 7. What do I need to do?
Multiply by the square roots of 7 on both.
On both.
Yep.
On both.
So on top, what do I get when I do that?
You get something over 14.
Bird 91.
Yep, square root of 91 over 14.
Dana, did you know that 91 is a prime number?
I didn't know.
It's a pregnant. What?
No, prime,
How
not
could it-
pregnant.
How could it be a prime number if you just multiplied 7 and 13?
Yeah.
I didn't know that. Oh yeah, we did do that.
Wait a minute.
I just said that because it looked funny. I don't know any immediately. 7 times 13 is not 91. That does not make sense.
What's the only even prime number?
What? 2.
2.
Two.
Not a 1-8.
All right. Now we get into some that are a little bit more difficult.
This is why no one
16.
thinks prime.
1 over 5 plus the square root of 6. So, there's a problem here
Oh, that's a big problem.
because I have a radical on the bottom.
No.
Oh no!
But what's going to happen if I just multiply by the square root of 6 over the square root of 6?
You get a square root on the top.
10 billion.
It'll
I
be
would-
11.
What?
Wait, no.
I'll get an
So,
there will be a
don't
before
write
and
this,
after
I'm
the
just
box.
showing you. If I wrote multiply by the square root of 6 over the square root of 6, oops, this would give me the square root of 6 over 5 root 6 plus 6. What's the problem?
Yeah, you still have a radical.
I still have a radical.
All right.
So, get rid of all that because that's false information.
The one point when I was looking, it didn't work.
What are you talking about?
I looked away for a second to grab a pen because I can't see my own handwriting. I don't know what just.
What? I understand.
All right, so we need to multiply by the conjugate. Okay, the conjugate is 5 minus the square root of 6. Top and bottom.
Oh.
Because what does this produce on the bottom?
Nothing. Oh, it gets rid of the negative, or it gets rid of the square root of 6.
But why?
Because it can't be in the
you
bottom.
have
They
it
cancel each other.
What special type is this?
A conjugate.
Difference of two squares.
Yes, it's a difference of squares, so it's going to allow everything to cancel out, okay? Like the middle terms that are going to have a radical left. So on top, I have 5 minus the square root of 6. On the bottom, first term squared is 25. Then it would be minus 5 root 6 plus 5 root 6. That stuff just goes away. And then minus the square root of 6 squared, which is 6. So my answer would be 5 minus the square root of 6 over 19.
Whoa, I get it.
No, you don't, Zach.
I just gotta learn how to show my work and then I'll figure the rest out.
I'm showing you how to show your work.
That's, yeah, look, see,
You just showed me.
I did show it.
18. 3 plus the square root of 7 over 2 minus the square root of 10. What am I multiplying this one by?
We're going to multiply this one by 2 plus 10, or plus 2 plus the square root of 10.
Yep, 2 plus the square root of 10. That would be the conjugate of the denominator. So the easy part is on the bottom. What do I get?
4
minus
plus
10.
5. 4 minus 10.
4 minus 10. Now on top, FOIL, what do I get?
FOIL?
Just like walk me through each piece. So I should have 4 terms.
6 plus the 3 square roots of 10 plus 2 square roots of 7 plus the square root of 7.
Yeah, Daniel. Happy birthday, Daniel.
So why did we FOIL?
Did I get your
Because the top is not a special type, so we had to FOIL.
Daniel, you should not do this.
So 6 plus.
I like them.
First, oh.
First person I've ever heard say.
Now, can any of the radicals on top be broken down?
Yes.
No.
70. No. Yep. No. No, okay.
It cannot. So the top is going to stay exactly the same. The top doesn't always end up looking pretty, unfortunately. So the top stays the same. So 6 plus 3 root 10 plus 2 root 7 plus root 70. And notice none of those things can combine because none of those radicals are the same over -6. And that would be your answer. So not a pretty answer, but nonetheless it's the answer.
You can only add if they have the same root.
Yep, it's got to be just like terms.
Okay, but when you add them, the roots don't change. The roots stay root 10.
Yeah, so if it was like
3 root 10. plus
hypothetically, yeah, so 3 root 10 plus 2 root 10 would be 5 root 10.
2. Okay.
Root 10.
They're just like terms.
Okay, that makes more sense.
Okay. The other stuff in here is actually solving quadratic equations. So a different method than what we did in the last couple of sections. So I've got s squared equals 169.
Ooh, 13.
No.
Is that S or 5?
S.
Okay.
So I take the square root of both sides. So I get S equals what?
S equals 13.
Square root of 160.
Positive and negative 13.
Positive and negative 13. When we take the square root in an equation, we have to do plus or minus. Okay, so there are two answers.
But when you're just doing the little mathy by itself without an equal sign, you don't have to do plus or minus?
Correct, because you're not taking the square root of something. Like this, like I'm taking the square root of both sides. So it's plus or minus. Because if I square positive 13, I get 169. If I square negative 13, I get 169.
If you were to write plus or minus on accident for something that doesn't have an equal sign in it,
It'll be wrong.
dang it.
Let's see.
That one was easy. We're stupid like that. I didn't bring mine.
24. X squared equals 84. X equals
The square root of 84.
Positive or negative?
plus or minus the square root of 84. Let's see if we can break down 84. What does 84 break into?
42 and 2.
42 and 2. What does 42 break into?
7 and 6.
What does 6 break into?
3 and 2.
Does 7 break down at all?
No.
No.
Alright, so I have a pair of 2's and I have a 7 and 3 left over. So this answer becomes X is plus or minus 2 root 21.
So, if you had 3 numbers by themselves when you were doing the little tree thingy, would you do all of them times each other? Like if you had 7, 3, and 9.
Yes.
Okay.
9 would.
Shut up, Zach. And you're dead.
I had to move out the way from my neck.
Yes, whatever's left over just gets multiplied by each other.
Can't look over your big.
Alright, 28. 7r squared minus 10 equals 25.
Oh, it's a difference of
You know,
two squares.
No, it isn't.
It is not.
No.
Told you.
I need to get the r squared piece by itself. How do I do that?
Add
Plus
10.
10.
So 7r squared equals
35.
35. Now what?
Divide by
Divide by
7.
7. R squared equals 5.
R squared equals 5. Now what?
R equals plus or minus 5.
No.
Square root of 5.
Square root
R
of 5.
equals plus or minus the square root of 5.
If you ask for a gross number, she gives you an equation. It's like solve it. My neck hurts.
Alright, 32. 7 times x minus 4 squared minus 18 equals 10.
Can't go that fast.
Do we have to do the weird factor thing that we did before?
Well, you gotta square it.
We're
Don't square it.
trying to get, we're just solving for x.
Okay.
So I need to get x by itself. So what do I need to do first?
Do the exponents first.
Add 18. 7 times x minus 4 squared equals 28. Now what?
Divide by 7.
So x minus 4 squared equals
4.
4. Now what?
X square it again. Square the x.
Square root everything.
I have to take the square root. So I get x minus 4 equals what?
Plus or minus the square root of 4.
Which is?
Plus or minus
Oh, 2.
So plus or minus 2. Notice the difference with this one is this was a perfect square. So I now need to split these to finish solving. So x minus 4 equals 2 or x minus 4 equals negative 2. So x equals
X equals 6.
6 or x equals 2.
Which one is it?
Either one.
Either one.
So why isn't it and?
Because it's
Because it's either or. It can't be both at the same time.
Because if you plug it in, you get the same answer.
Okay, so both of those numbers work in solving the equation, right?
Yes, but it can't be both at the same time. X can't be two different values at one time.
Yeah.
Technically, all of these should be written r equals the square root of 5 or r equals minus the square root of 5. I'm just being nice and letting you combine them. My professor in college was adamant that you were never, ever, ever supposed to do this, and this was bad math. and he's not wrong.
Man.
Is
But-
he fired?
What?
Did he get fired?
I said he's not wrong.
Oh, I was learning a lot better this way.
But it's going to confuse you if you don't know that going down here.
How old is
So,
your professor?
like mathematically, the reason is S can't be 13 and negative 13 at the same time.
That
Okay.
makes sense. That makes sense.
So that's why it has to be or, but
Oh.
I'm not going to make you write them separate unless it's something like this where you're actually solving for a final thing.
Okay.
3, 7, 9, 11, 17, 23, 27, 31.
Did you show your work line?
You can just sit right there.
I hope you